one, we will talk about AI tools. 4 things. First thing is the coding or the computer language that you're going to use. That's the basic thing because that will determine everything. And then after we select a coding language, the next thing that we will need to do is to talk about different tools that people built on the coding language for different purposes. And for AI, we will need a few of them. The first thing is the tool for data manipulation, visualization. So we get tools, in many cases, they're sloppy, there are lots of things are missing. So we will need to do a lot of modifications, a lot of pre-processing to make sure that we will get what we want. And also we will need to have a tool so that we can do the visualization. We can see what the data looks like. And also after we do some work with the data, using some AI tools, we will get some results. We also need some tools to help us to take a look at the results, what it looks like. Just like what you did in the previous lab, you have the original label, then you do the prediction, right? Then you compare those 2 things to see whether it's good or not. In a very simple way, like what you did in the previous lecture, you will see that if the training is not that well done, you will have those dots corresponding to the prediction, the comparison between the prediction and the actual labels. They're everywhere, right? They're scattered. Second, we will need to have some tools for machine learning, the basic machine learning algorithms, and also for data analysis. The third one is when we want to zoom into machine learning, especially for the new deep learning and reinforcement learning area, we will also need to have some other tools that are more customized for the deep learning purpose. So we're going to do it in this way. First, I will offer a very quick overview for the coding languages and the tools. Then we will talk about 3 of them for data manipulation and visualization. They are NumPy, Pandas, and Matplotlib. The third one for machine learning and data analysis, we will go through just one tool, is the Scikit-learn that we learned that we used in the previous lab. Finally, for deep learning, I will offer some information about TensorFlow and Keras. These will be the 2 major things that we will use for deep learning. First, language and the big picture for the tools. Regarding the coding language that we can use for AI applications, there's a lot of them in the field, and one major one these days is Python. So when you talk about coding language for AI, most people will say, oh, let's go with Python. And after Python, we also have Java, R, MATLAB, and there's also some other options. And regarding the tools, so when we say tools, we say packages that we build up using the coding language. Here, this is a scope that I used to tell the story. Here you can see that we have different levels. At the bottom level, we talk about the coding language or the coding environment. For example, when you say Python, in this course, we don't use the original Python interpreter. We use a Python distribution, including the interpreter and many other common packages. Something including the Spider, which is a IDE, is a development environment that you can use to do everything together. And so we go with Python, and also you guys possibly remember 10 years ago, MATLAB is like predominant in the engineering applications, but these days, due to the rise of AI, now many engineers switch to Python. But MATLAB, they still have some new things for AI, and that's another very popular option before Python. R is a very popular language that people would use to do data analysis, statistics, things like that. And then above the coding language, that we can something that has been developed by people for data manipulation and visualization, or for example, first is, I forgot there's a typo here, it should be NumPy. NumPy is for array operations. So when we are doing AI, one common thing that we need to deal with, they are arrays, 1D array, 2D matrices, something like that. And if we use an engineering language, many of us would say, oh, vectors, tensors, that's a different type of thing. But there could be the same thing. There are just different ways to talk about the same thing. So when we have very complicated data, when we say data, they're not like numbers scattered everywhere. We organize data in specific formats. Those are arrays. And for arrays, when you have, for example, one 2D array, you need to know how to work with them, right? That's operations. For the operations, and NumPy, the package, or NumPy. NumPy can do the work for us. Then the next one is Pandas. Pandas is something for complicated data. So when you have not just numbers, you have many other things, and also you have a lot of glitches in your data. You want to do some modifications, do something that's similar to what people do in some database software, pulling data, do some modifications based on some rules, something like that. Pandas is really good at that. Matplotlib. That's something we use for data visualization, for plotting very 2D curves, 3D surfaces, something like that. Very good. And there's some other things we will possibly don't have time to cover in this course. First one is the SciPy. That one provides a lot of advanced mathematical functions, something that you cannot easily do, for example, using NumPy. And we also have another tool, for example, the Seabone. That one is good for advanced visualization. The Bouquet is good for interactive visualization. And above the data manipulation and visualization, those are the common actions that we would take when we are doing machine learning. Then above it, for machine learning, we're going to be working on one major one, that is the Scikit-learn. It includes most common machine learning algorithms that you will possibly need. So it's very good for, it has things for unsupervised learning, evaluation, and data sets. TensorFlow is another option. TensorFlow is complicated, so you can see that it crosses two different layers. You can use it for deep learning, or you can use it for machine learning as well. It's actually not just developed for machine learning, they can also for some other purpose. It's good for parallel computing, for computation on different machines simultaneously. So it's good for that purpose. And machine learning, deep learning can be used, both of them can be done using TensorFlow. And for machine learning specifically, we can use Keras. Some people say that TensorFlow is the back-end lower thing, and Keras now can be built on TensorFlow or something else. For example, Theano. That's something a lower-end thing for more for computation. And these days, PyTorch is also very popular in the past few years due to some issues, hard to learn, some other issues, hard to understand. With the TensorFlow, many people switch to PyTorch, and now TensorFlow you try to improve and attract more users back. Another popular library or framework, that Cafe, it was very popular several years ago. We also have MixNet. That's another popular option. And regarding Theano is another one. And for reinforcement learning, this topic is kind of separate from the other machine learning topics. And for that one, OpenAI Gene, that's something that we will possibly use when we are talking about reinforcement learning. So this is kind of the big picture for the tools that people will use and that we will use in this course for AI. And first, let's take a look at Python. The first thing that we need to know about is that it's a interpreted language instead of a compiled language. There's a big difference. I'm not sure if you guys have worked with coding languages like C or Fortran before. The way that they work is that you write your code, right? Then you compile the code into something that the computer can recognize, and the computer will execute the comments in that way. But for the interpreted language, it's like you don't talk to the computer directly. You have something between, and you have to say something, and that interpreter will translate what you said and to the computer. The computer will do that right away. So you say something and do it, and the computer will do it if they get the message from the interpreter. So we will need something between. That's the major difference. And many people prefer Python because it has a very simple and elegant syntax. It has very good readability. We use those indents thing to show the layers. Some people say that it's a glue language because use things with different languages. Python can be used to connect different parts. It's versatile. It's versatile not just because the original Python is good. Original Python is very simple, elegant, but it's very simple. You want to do it with it. That can be really challenging. It is. Many people say Python is good, but people means that Python and the packages built on it are good, not just Python. So the real functionalities come from the packages, not the original Python. And it's portable. You can do it on any types of operating system, Windows, just like what we're doing here, and Linux. If you are doing research, you probably need to get in touch with Linux a lot. And of course, if you use a Mac, it's similar to Linux. It's a Unix-like operating system. Many people criticize that it's slow. It's true that compared with, for example, C. However, this issue has been gradually improved. Many people propose some other packages so that the execution speed, the computation speed can be increased significantly. There's many packages that can be used for that purpose. And regarding how to learn Python, again, the easiest way, I think, go online, search many things. For example, learn Python in 10 minutes, 20 minutes, 1 hour, you'll get a lot of things. Just watch one or few of them. And if you don't like any, switch to the next one. There are many of them. Some of them, they're well done. Some of them are not. And also, of course, go to the book chapters, the reading materials that I share every week. Sometimes they can be long, especially for the first few chapters, 50 pages, 30 pages. You can choose what to do, and I also give you guys some hints regarding how much time you need to spend on each sections and subsections. For later chapters, they're much shorter. Sometimes they're 7, 8 pages, sometimes they're 15, 20 pages, but overall, they're shorter than what you have got for the first 2 weeks. And the other one is some other things, for example, W3 School. That's another very good place that you can learn Python very quickly. Just start with very simple ones. And one point that I want to make here is that in this course, we only need to know the very basic things, Python and any other tool. We don't need to know those fancy stuff. And it's okay that you just need to know, have a general idea what this thing is about and how to do it in general. You don't need to remember every function, every comment, or the parameters in it. To be honest, I cannot remember any of those things. You know, do that every time I need to do something, I need something, I know what comment, what function I may need, go there, search it, go to the web page for that function and manual, read it. And if that's not helpful, switch to a different page, find one example. In that way, you can get to know something very quickly. And it's for the elements do we have in Python when we say that, we just need to know the very basic things in Python here. First, basics, what it's about, what's the basic syntax, right? You need to know something about indentation. You need to know when you should put a column there, when you don't need that, right? How to make a comment. So that's part of the basic things. Some time on it, not just need, like I said, 10 minutes, 20 minutes. Then you just need to practice to remember the basic rules. You need to know the variables and data types very well, especially something like list, dictionary. Those are the basic things. But in Python, in general, it's very easy to deal with the variables and data types. You don't even need to declare a variable before you use it. For example, in function, you need to declare it. Variable is data type before you can use it. Now you don't need to in Python. For example, for a constant and a float number, you just need to put like a point there to tell the difference. And the computer can know that. And you need to know the operators, the different operators, arithmetic operators, multiplication, product, division. You need to know assignments, how to assign a value to a variable. You need to know how to do the comparison between different variables. You also need to know something about logical operators. So you have one condition, second condition, how to combine them. There's some other things such as identity, membership, bit ones are not that common, so don't worry about it. That's why I put them in gray. Then is how to control a process. Because when we do a machine learning algorithm, we have something called pseudocode, right? Pseudocode help us to understand what's the procedure. Assign some values to some variables, then do some iterations, something like that. And you have different conditions. You need, depending on what you get, for some variables, you need to do one thing, or in another different condition, you do another thing. That is process control. For that one, you need to know the conditional statements for handling different conditions. You also need to know the sequential statement, the loops. We have 2 basic loops in Python, and you need to know how to use that. And you may also need to know a little bit about functions, not too complicated, just very basic, so that you get to solve a problem and you don't want to do it from scratch. And I let you know that you can copy something online. Then do it. Don't hesitate to do that. But when you get the code, you need to have the ability to understand the code. In many of them, they have include a lot of functions. So you need to understand how to read the functions. And finally, you need to know input and output. You need to, for example, how to type in something and assign that value to a variable, right? That's the input function. You also need to print it out. That's print function. You think you already got some practice in the previous lab. Some other things that you will possibly need in your future labs, That is how to import and export from or to a file. That's another big thing. There's a lot of ways for doing that. Finally, for object-oriented coding, for illustrating like machine learning algorithm, this is not necessary. It will give us complexity. So I'm trying to avoid that. However, if you try to get some code online, some of them in this way. And if that's the case, you want to make sure that you know the general idea of it and how to understand the code in that way. It's not very common, but it may happen. And then first for NumPy, as I said, num is for numeric and pi is for Python. So many people pronounce it as NumPy, but NumPy is kind of a more natural pronunciation. Both of them should be okay. Let's go with NumPy. NumPy, talk about the whole thing about NumPy is how to define and how to deal with arrays. But this array thing is a NumPy thing. It's not something associated with the original Python. So you will need to import NumPy before you can use the array or NumPy array here. And one common question people would get is that what's the difference between a Python list and a NumPy array? Python list is something that we can create with the Python, right? Without any other packages. It's very simple. You just put things, different numbers into, or even other things, strings, into one pair of brackets. In that way you will create a list. And a NumPy array can be generated using list. A difference between them is that, for example, let me make a very simple example. If you want to get every element in, for example, a Python list by 2, you cannot just time this thing 2. You cannot do that. Do it, you will still get something, but believe me, that's not what you want. However, if you define array in that way, it's very simple. For example, the whole thing 1, 2, 3, 4 inside the brackets, that is a list. Then you create a NumPy array with it. Let's call it A times 2. In that way, you will get what you want to do. That is every element inside that array with 2. So that's why we want to use, and there are many other operations like this, and you cannot easily do with the Python list, but you can usually do with the NumPy array. And some of you may be MATLAB users. No, I did it in this way, so I knew how to use MATLAB. However, when I started looking into Python, I found that, somebody developed something like web page, Python for MATLAB users. Go there, that's one page for NumPy. It shows you the comparison between the ways that you would do it in NumPy and the way that you would do it in MATLAB. So here I just show some very common information. And one major difference is that in how we deal with something called element-wise operation and the block operation. For element-wise operation, for example, you multiply A as a matrix by something. In that way, if you use this sign, then you do the element-wise operation. On the right here, in MATLAB, you can see that you use a dot and this star sign as asterisk sign. That's you do MATLAB, so you need to use 2 symbols to do element-wise. But in Python, by default, we do it in this way. 1 asterisk will give us the element-wise. If you want to do something, so for element-wise, that means you want to get the product between the corresponding elements. For example, the product of the first element of A times the first element of B will give you the first element of their product. Let's say if it's C. But the second element is the same thing. And in that case, that means A and B need to have the same shape, same signs along different axes or different dimensions. But you have something else. You want to do a dot product. That's something different. That's kind of like a array thing or a matrix thing. I can move to the next step, show you a little bit. I mentioned this because this is a confusing thing when learning this. And we will need to use different types of products, operations frequently in our future learning. For example, if you have something like this. In Python, if you do this, it will give us the element-wise product. When we say A asterisk B, this is what happens. A, B, you can see that you get a product, and first element in B, their product will become the first element in C. And in the book, you will see that I use this O dot sign. It's a circle with a dot in it. And then when we move to something else, for example, it's very common that we will have something called a vector product or dot product. That is, in NumPy, we use A add sign b, or an equivalent way is you use a function, it's NumPy dot, then put a and b, then you will get the dot product. So if you go to an engineering book, when we are talking about dot product, we would say it's a dot product, for example, a vector product between two vectors, vector a and a vector b. So if we only have one number, that's called a scalar, right? When we have one array of numbers, it's a vector. When you have something that has two dimensions or more than two dimensions, that's more like a general tensor, right? Vector is a special tensor. We have a vector, we put an arrow sign in it, just like velocity. Velocity have three components, x, y, z, right? So A, B, both of them, then we do the dot product, then we put a dot sign between A and B, that's a dot product. And to do the dot product, and we got the same issue, is something like this. So if we're talking about how to do that, you can see that it's different. Now, for example, for a element-wise, it's 3 rows, 1 column, 1 times 3, same shape, right? Here you can see that if you do it in this way, it's gonna be 1 times 3. Then for the B, it's going to be 3 times 1. Then the dot product between them will give you something with the shape of 1 times 1. So 1 row, 1 column. That is scalar, right? So we get one number. And it's another function from NumPy. It's called tensor dot. This is a more general one. It includes everything. So for this one, if you use and put something here, x equals 1. Then what does give you would be the same thing as this one, as this add sign, this dot product. One. This one? Oh, second number 2. You guys are good. Thank you for catching this. My bad, I should go back to the elementary school. Get more practice with this. Anyway, so for this one, you can see that you will get one number and do it this way. And when a few cases, we will deal with another more complicated product. In engineering, in tensor analysis, we call it outer product or tensor product. So for this one, for example, if you get 2 vectors, there's nothing between them in tensor analysis. If you get something like this, it will be equivalent to something like this. This outer product thing or tensor product sign between B. There's either nothing or this sign. Then you will get a tensor product. For example, A and B, both they are vectors, 1D array. Then in that case, the tensor product does is that you need to do it in this way. Compared with previous one, you see that it's like that way. Here is a row array times a column array here. This dot product, this is inner product, dot product, inner product. This outer product or tensor product. So for this one, you're gonna have a column array times a row array. In that case, you will get this. You can see if you take a look at their shape. This is 3 rows, 1 column, 3 by 1, right? And this one's 1 by 3. So you get the outer product of them, you will get 3 by 3. So you can see that this is the 1x. If you're using a matrix language, right? NumPy language, the 1x. We talked about what is x in NumPy array before. And now if you use tensor language, this is called first order vector. First order. Then you here got 2 dimensions, so second order. It's the same thing, just different languages. And we are in engineering. That's why I want to bring this up. It's different from what you will get from a very typical machine learning book. If you don't understand this, please spend more time in the chapter in your week 1 reading material. There's one section for math, and in it, there's one subsection for tensor analysis. And you can compare this one with what you can find with this comment, with this tensor dot function in NumPy. And to do that, the difference is that one parameter is a key thing. You assign the axis. That's how one word from tensor analysis called contraction. Contraction means that you will kind of 2 axes in arrays, or you will reduce, for example, 1 dimension from one tensor, another dimension from another tensor. So you will reduce the total numbers of dimensions, orders, by 2 by doing a single contraction. And axis equals 0. That means you don't do any contraction at all. Just like here, you have this first orders, right? You have this first order, 2 first order tensors or vectors, and then you do this outer product. There's no contraction, so that's why here axis equals 1, this parameter equals 0. In that case, 1 order one, then the product of them will give you order 2 tensor. So that's why here it says axis equals 0. That means outer or tensor product 0. 2. So vector, it has the first order tensor, right? And this one, A is the first order tensor, B is also first order tensor. So you get a product without doing anything, then you get a second order tensor. So that means we do any contraction, that's outer product. So the inner product or vector product or the dot product in the previous slide, just like, first get a product of them, then we do a single contraction. You do one single contraction, then you will reduce the total number of orders by 2 because you kind of 2 axes. So this first one is a first order vector or is an array, 1D array, 1 ax. You combine them, in theory you should get a 2 axes, right? But you do one inner product, it's like you have one single contraction compared with the outer product or tensor product. And then in that case, you merged those 2 axes and it'll turn into like 0 axis, just one value here, one number. It may be a little bit confusing, but at least I want to bring this up early so you guys know, oh, there's something there. And you can find something in your reading materials in the final. You encounter any of these things in your future. Oh, here is when we Pandas. So for Pandas, for different packages, they define their own data structures and the methods, the functions that we can use to play with the data organized in that data structure. Just like a NumPy array, that's one type of data structure. We have a lot of functions, methods defined in NumPy that can be used to work with the NumPy arrays. In Pandas, there are 2 other structures that we need to know about. One is called a series. The other one is called a data frame. You can understand it this way. Series is just like one column here, and data frame is like 2D thing. Compared with NumPy array just deal with numbers. But here, you need to deal with some other things. For example, on the top, just like for the attribute names, how you do that, now Pandas gives us a name. And you also have either implicit, something that's hidden, or explicit here on the left for each sample. So we also have the same concept, axes, just like what we had before for NumPy. Axis 0, axis 1. For matplotlib, it's not difficult to do that. You just need to get some practice. But there's one very confusing thing. That is, there are 2 different ways of using matplotlib. If you search online, sometimes you get a much different code for the same task. You get confused. Oh, what's the difference? Actually, there are 2 different ways. The first way is called a functional or procedural way of doing that. And this way is pretty similar to the way that we do generate plots in MATLAB. You have x and y. You use one function, just plot it, right? Very simple. You want to do something, you want to change the title, you use one function comment to change the title. You will add a legend, you add something to it. So you can see that is a very typical code. You generate the x using the line space function from NumPy, and then do the y, 2 y's. You want to plot 2 curves. You have 2 y's, y1 and y2. Doing that. Then you just want to plot the first curve. So x, p, l, t, that's from the matplotlib pyplot module. Inside it, you have this plot function. And then inside it, you just need x and y1. And on the right, there's a few other things that you can add more attributes to the curves that you want to plot. Instead of using the default settings, you can specify, for example, the color here, put an R here, and it means color, and use this asterisk thing, tell you, you're gonna use this sign as the dots. Then you also can put a label here. For the second curve, we do it in a very similar way. Then we want to label the x1, label the y curve, the x title of the plot, the y title, and the title for the whole plot. Then we want to add a legend into it. Here you can see that for the legend function, you can specify the location that you want to place the legend. Finally, in many tools, you want to use this show function so that your plot can be displayed on the screen. This is the first way. Second way is called object-oriented plotting. So when we say object-oriented plotting, it's similar to object-oriented programming. In the object-oriented programming, and then everything is treated as an object. So you build something, then you build one object, you build another object on it. So keep doing that, stack things together so you can build whatever you want. And in this way, so to do it, first we need to understand what objects we have in a typical scientific plot, right? here shows the thing. And you can see that first we have something like a canvas, right? Some people call it a plot. And then we have something called an axis, A-X-E-S. So you have multiple axes in that way. Because for example, in this one you have X, you have Y-axis, two of them, but they form one plot, subplot. That's called axes. You can have multiple different subplots in one plot. And inside each subplot, you have many other things such as a line, such as markers, such as ticks, major ticks, minor ticks. You have a label, you have the Y label, right? So the way that we do this is that we define something, object first, then define object that we need to build on top of it. So if you take a look, that's the second way. You do it in the same thing, define X array, Y1, Y2 array. Then we will need to define the figure or the plot. And the AX1, that's axis 1, that's the subplot 1. In this case, because we only have one subplot on the canvas, so we don't need to do anything. You can see that it's empty inside the parentheses right after this plt.subplot thing. There's nothing in it. That means we don't only have one subplot. Then the current subplot AX1, we want to plot something. So in the first subplot, we want to use the plot method belong to it. Then plot X, Y1. Okay, the first curve, do it in the same way with the second curve. Then we want also in the first subplot, we want to use the set title. You can see that they use different. They're different. This called set title, the other one called title. They're different. And then you get something. And do it in the same way. You can assign different attributes to different objects. So you can build up things on the top of the previous one based on their relationships. So
what is the last one? Title, like difference? Or
this
would just put title there?
Yeah, you can do it twice. So you can say something and the second one will overwrite the first one. It's the same thing. So this is another example. When you have multiple subplots, you use something like this. For example, you're going to have 6 subplots in this way. You have 2 rows, you have 3 columns. So the way you're going to do it, you're going to finish the first row, first, second, then go to the second row, third, fourth, then go to the third row, fifth, sixth. That's the way you number it. And 2, 3, 1, that's first you show the setup of the subplots. Then 1, the last parameter, that means the number. That's the first subplot. That's the first in the first row. And then here you use PLT-SCA. You assign AX1. That's 2, 3, 1, the first subplot as the current active subplot. Then you can use the other things to of it. Just you move to a different subplot. You do the same thing. First switch to the active subplot to a different one, and then change the properties of it. That's for plotting. And next, for Scikit-learn, you have already got some experience with this one, right? That's a good thing. And for this one, I just want to mention a few very general things. It's the most useful, robust library for machine learning in Python. It's very well organized. It's called library, and it's largely reading in Python. It's built upon a few other packages, NumPy, SciPy, and Matplotlib. And this consists of functions that we can use for regression, classification, for supervised learning, and dimensionality reduction for unsupervised learning. For reinforcement learning, we need to use something different. There's another one called Scikit-learn, but that one is not well as developed as this one. And functions in other categories, not just the algorithms. We also have many things for feature extraction, data processing, model assessment. They're all available. And Scikit-learn or sklearn also provides many data sets, toy data sets, and more advanced ones to facilitate the development, comparison, and assessment of algorithms. So here I just give out some very simple examples to show you how to import data sets. You've already done it, right? And how to import it from files. We haven't done it, but you can. Here's one way we use NumPy. I'm not sure if sklearn has of doing it, but as I said, many tools, many functions from different packages can be used for this purpose. Data processing, here's one example for standardization. In machine learning, it's very common that we want to squeeze input out of a range, for example, between 0 and 1, between -1 and 1. And if you guys spend some time to take a look at that diabetes data set that you used in previous lab, you will find that target label has is in our numbers, right? And the range is from 0 to like 2 something. Take a look. And you can imagine that when you switch to different engineering application, someone give you some data, your output, the label is not is what you measure. It can be anywhere, right? It can be 0.005 in some cases. In some cases, jump out very quickly, go to 10,000, even higher, 1 million, something like that. If we have something like that, and different people give you different data, they're in total different ranges. And if you use some data like that for machine learning, you'll find that sometimes you got very bad results. And one common way to improve that is to do the standardization or normalization, the different techniques to make sure that all the data look very similar, same range. And also that will also facilitate your right? If one something, you have different range, then how you can tell, how you can compare different things in different ranges. And in some cases, it's necessary. For example, in deep learning, we'll learn that later. We have something called an activation function. They may squeeze everything into a small range between 0, 1, or -1 and 1, depending on which function that you will use. And something that you will get will also need to be in that range so that you can use the algorithms the other people have already developed. And another thing is called one labeling. That's also another very useful thing that people use in deep learning. And another thing, everybody possibly need to do in this class is how to split data. In the first lab, you guys found some code online, but we said that just skip it at this moment, and because we just want to get a taste of machine learning. But here now in the future, we will need to talk about training and testing separately, and for that purpose, data split is something that we will need to know. And Scikit-learn presents very good tools for doing that. For training and use models, very simple, very neat. You can see that, import it, then assign it to something, then use a method fit in it. If you want to do the prediction, use another predict method associated with the algorithm. It's a new class. And then save and load model. This is also very useful because you do something and you don't have time for it. You want to work on it later on. You save it, right? Come back. Then you will start that breakpoint instead of start from scratch. And also, if you have a peer student who want to use your work, have already got a very good model for something, and that one you want to use that model instead of the blank algorithm, right? And then what you can do is that, I save the model, you take it, then load it, then you can start from the one that can give us very good results instead of the start blank model. Then for learning, TensorFlow, this one, as I said, it was developed for not just for deep learning, is for facilitate the parallel computing, give us high computational efficiency. However, it's very popular in the deep learning area. You can use it in two different ways. First, just use TensorFlow, the basic functions. Second, we can use something built on it, for example, Keras. So Keras, that kind of thing. And you can take a look at the structure. We will have something called API. That's application programming interface. For APIs, you can imagine that there's different tools on different layers that can help us do different things. We have, so the TensorFlow can run on different hardware, CPU, GPU, TPU, Android, and above that, we have, for example, the Python core TensorFlow API and the C++ core TensorFlow API. Usually we use the Python one. We'll give you the full control over everything. You can use it to do different operations with different data, do the computation, even do some other things. And then on above that, we have the mid layer. For example, you have some other things. You want to create a neural network, then you have layers. You want to generate a loss function objective for solver optimization. We use tf.losses. You want to evaluate it, we have tf.metrics. And then we have higher level API for distributed training. So for this one, you can get a much higher computational efficiency. That is TensorFlow. And one thing that's difficult to understand, there's one thing called graph. Graph is the thing that we define how we're gonna play with the data, how we're gonna use the data to do the computing. Because no matter, if you do a deep learning, machine learning, basically you just tell the computer how you're gonna play with the data, right? And TensorFlow use graph concept to do that. So in the graph concept, for example, here you use A and B, you have two different arrays. Then you want to add A and B up here, then you need to develop a graph like this. It's a conceptual thing, it's not a real thing. A, B, then use the divided by TensorFlow, for example, you define a node here, you put a constant here, and node 2, the constant, then you define a node 3, it's an addition operation, you add them up, Then you create the graph. But it's a graph. It has not been executed yet. So in TensorFlow, in the TensorFlow 1, now it's 3 now, 2. So in TensorFlow 1, the way that we do it is that we need to define a new something called a session. In the session, we will run, execute that graph. And execute it will give us C. That's what we want. And we close the session. We have many other things. For example, here we only use constants. We can always have variables. So variable is something that can change as you have different conditions, different data. For input, we would have something. So when you define the graph, you don't know what is the input, right? So they use something called a placeholder. You just say that, oh, there's something I'm in. That something will come from the user. And then that one will do something with some other things or another variable, and that will give us something. And next is Keras. Keras is something that can be built on TensorFlow or some other back end. It's a front end thing, and it's very higher on a very higher level. That means when you say that it's higher level, that means you have less, so everything has been fixed. However, you get more possibly functionality and convenience. You don't need to build up everything from scratch. They have to tell you, how you use one comment to do something. For example, in Keras, you may only use 2 lines to do something that you possibly need to use like 10, 20 lines in TensorFlow, but they will do the same job. So here in Keras, there are 2 ways of building for deep learning, right? It's for deep neural network. So the first way is called a sequential way. This is the easiest way. But this way is simple, very easy to use, but less flexibility. So you need to follow it in the exact same way. How to do it? You import everything in the first 2 common lines. In the third line, there's one thing called sequential. Sequential is like in the first letter is capitalized, right? According to the Python coding convention, that means that it's a class. So in this class, it's a template. So you can use the template to build up the things that you want. In the template, you can see that it's from here to all the way to the end. And between them, you can define what layers you have. First layer is a convolutional 2D. It's a 2D convolutional layer. And you define some other parameters. How many filters you have? What is the kernel size? So after you learn deep learning, you will know the meanings of those things. The second layer, third layer, there's a pooling layer, the dropout layer. That's all of them are concepts from deep learning. Then another convolution layer. So layer by layer, all the way from the start to the end. At the end, we have a dense layer that will give us 3 numbers as the output. So that's how we build up a network sequentially. The second one is called a functional API. So this one will give us more flexibility. You don't need to use that class to do everything. So instead of how we do it, you can see that all important things that we will need. Then first use this input, create an input. And then you can see that in the line below it, we use convolutional 2D, something that's very similar. But on the right, you can see that you have 1 pair of parentheses, input that you just defined, whereas the input of the second layer, right? And it will generate something called X. X is the output of the second layer. Then if you move to the next layer, you will see that this X will move to the end of it here. So the first layer becomes the input of the second layer. Then you generate another X. They use the same variable, but they're different things actually. So this X again in the third layer, the output, the X on the left of the second line will become the thing on the right of the right end of the next line, next X. So input, you use this layer, will generate another output. You keep doing that until you get the last layer. See that you get predictions. That by final finish all the data, go through all the layers of the deep neural network. You get the predictions. And after you finish that, you need to do something. You need to do the compile. Use this thing. So you define the network, but you haven't done anything yet. You just draw the map for your network. Do the compile. Then that thing will define some other things. Define what is the loss function, right? Well, how are you going to solve it? What's the solver or the optimizer? What is the metrics that you want to use to evaluate your training? And then we define a few other things. How many epochs that we're going to have? There's another kind of deep learning thing. The batch size, usually we don't feed samples one by one in deep learning. We use batches. We put multiple samples in one batch, feed them, and then do the training, and then move to the next batch. Then use the fit, the same fit score generator, right? That's something we use for training. So this one, you do the training and you get what you want. And if you run the whole script file with all the code that we just went through, then you will get results here like this. We'll do it. There you go. So this is a lecture we need to cover. I apologize that I didn't spend too much time on it.
Think I'm falling for you.